Water, one of man's greatest necessities. In the modern world, water is often taken for granted. But in many arid areas of the world, the poor have no access to pure water. In portions of southern India, in the rain shadow region of the Western Ghats, there are no major rivers, and the people are dependent on seasonal rainfall. During the rainy season, the canals and lakes usually fill up, for a time supplying the necessary water. But during the dry season, these water sources dry up. The land looks up to the sky, as the local villagers say, and has often presented a depressing scene. Living conditions in these remote villages are very difficult to begin with, but the lack of water can make life unbearable. Often, the only sources of water are terribly polluted. In many villages throughout India, the water has a high fluoride content, which can cause bone deformities and damage to teeth. The villagers have been compelled to use the same water they use for bathing, washing clothes, and watering cattle for their drinking water. In these same remote areas, the water needs to be transported from its source. And often, any water, no matter how polluted or how far away it is, has been used. The suffering of these impoverished villagers is an old phenomenon, but seldom has their cry of anguish been heard in quarters that matter. In Anantapur district in Andhra Pradesh, one of the driest districts in the state, 100 years of appeals to higher authorities brought no relief. But in early 1995, one determined native of this district decided to change things forever. That man is Bhagavan Sri Satya Sai Baba. Born in the village of Puttapati in Anantapur district in 1926, Baba, or Swami as he is known to his devoted followers, holds pure love as the highest guiding principle of life. He has dedicated his entire life to the selfless service of humanity in innumerable ways. Baba launched through the Sri Satya Sai Central Trust a massive project to provide safe drinking water to 731 villages in Anantapur district, covering a population of nearly 1 million suffering villagers.
Today, water supply, Anantapur Jilla Lopala, Andhra Pradesh సంబంధించినటువంటి ప్రైమ్ మినిస్టర్ వచ్చి ప్రారంభించడం నిజంగా ఇది చాలా ఆనందించవలసినటువంటి విషయం.
It's a joyful occasion that the water project is inaugurated by the Prime Minister who belongs to the state of Andhra Pradesh.
The project, costing nearly $70 million, involves massive excavation, blasting, extensive pipe laying,
So, have you all heard of Abdul Kalam? Right? He's one of the presidents of India whom we are all very, very fond of, so much so that he's referred to as the people's president. It's a gem of a person. Swami's devotee, of course. And I don't know if you all know that when he became the president, the first salary that he drew as the president of India, he sent it to Swami. And in the covering letter, he had written, Swami, if my mother was alive, I would have given my first salary to my mother. Now that she's no more, I want to give it to Swami. Right? It was a gem of a person. He tells this about his early career. From his childhood, he was very fascinated about becoming a fighter pilot. He always said, I want to become a fighter pilot. He started working hard. He was a very good student. But the thing was, if you want to become a fighter pilot, you need more than brains, right? Brains and bronze, they say. But he was a very studious student. So he covered the intellectual part, but in the part of the physics and all that, he was not there. So finally, after having this dream and nurturing it and working on it, he goes for this exam selection process, which is meant to be for this fighter pilot. They were supposed to recruit 12 people. He comes 13th in that list. And he misses this dream of a lifetime. Short lifetime, nevertheless, but a dream of a lifetime. He always wanted to be a fighter pilot, and he misses that. And because he misses becoming a fighter pilot, he takes to atomic physics. And what happens? Takes to atomic physics, then becomes one of the leading scientists, nuclear physicists. Then he becomes the scientific advisor to the defense ministry. Again, you wanted to be a fighter pilot. One of the small components of your defense mechanism, he becomes a scientific advisor to the defense ministry. Then what happens? He becomes the president. And who is the president? He is the supreme commander of all your defense forces. He did not get what he wanted, but imagine what he achieved. Had he lost heart at that, had he said, oh God, gone now, all my life is gone. You have the self-confidence, you have the hard work. I mean, his name is synonymous with hard work, right? You would say sweat and blood, sweat and blood, sweat and blood. Invest sweat and blood into anything, you will see success. That's what he would say. So that self-confidence and that hard work, if not this, wherever he had gone, he would have reached the pinnacle.
Happy birthday to you, Sai Baba. 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 Happy birthday. Happy birthday to you, Sai Baba. 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 Happy birthday, happy birthday, happy birthday to you, sweet Baba. Happy birthday, happy birthday, happy birthday to you, sweet Baba. Happy birthday, Sai Baba. Happy birthday, Sai Baba. Happy birthday, Sai Baba. Happy birthday, Sai Baba. Happy birthday, dear Satya Sai Baba. Happy birthday, dear Satya Sai Baba. Happy birthday, dear Baba. We love you, sweet Baba. Happy birthday, dear Baba. We love you, sweet Baba. Happy birthday, Sai Baba. We adore you, sweet Baba. Happy birthday, Sai Baba. We adore you, sweet Baba.
Thank you. Thanks, Sai Krishna, for playing the wonderful videos. And the last video was very beautiful, and it was a nice musical treat for everybody. I hope everyone have enjoyed. So the reason for you guys to show these videos, basically, we want to know, we want to let you guys take this opportunity and let you guys know what exactly is being done inside the Sri Satya Sai Seva organizations. Like, it was just one of the service activity which they do in a large scale, the water projects. There are other projects like the medical health, free health medical benefits for all the people in, like, there's a big multi-specialty hospital in Puttaparthi and Bangalore, where they do all the major surgeries like heart surgeries and all other major surgeries for absolutely for free for everyone. And also there are India's renowned, one of the top universities, Sri Satya Sai Institutes of Higher Learning. They offer education, free of cost for all the students, right from their kindergarten until like post graduation and PhDs. So it is a really great, one of the top universities in India, and the students, alumni of Sri Satya Sai Institute of Higher Learning are in one of the top positions across in big companies across the world. Not only in India, they're holding very big positions across the globe. So, and one of the video you have seen about our former president APJ Abdul Kalam, he was a very ardent devotee of Bhagavan, and he used to visit Puttaparthi very often, and he shares, he really he's a devotee of Bhagavan. And not just him, like there are many other top uh, uh, big personalities who all are followers of Bhagavan, and we get inspired from Bhagavan because he has taken a human form and does such a wonderful, he did great wonderful social service activities for all the people, needy people. And we take that inspiration from the Lord, and we try to do some kind of activities whichever we can. So we thought like we will do this virtual event of doing the reprogramming lives. So during this pandemic, we don't want to stop. Even if it's a pandemic or something, we still want to go ahead and continue our service activities irrespective of a pandemic or no pandemic. We want to be part of these such great activities, and that's the whole purpose. And I won't take much of you guys time, and I don't want to take more time of Prasanna sir's class, so I'll stop here. And once again, thank you all for your patience. And Prasanna sir, you can go ahead with your session. Thank you very much. Sairam.
Sairam, thank you, Ravi, thank you. That was quite inspiring. I think the videos were also quite inspiring to see Bhagwan Sri Sathya Sai Baba sowing the seed of Satya Dharma, Shanti, Prema, Ahimsa, and service. More importantly, I think the emphasis is on service. So I think it kind of inspires all of us, and I think we all get inspired from his teachings and from his leadership qualities with respect to especially on the seva side, especially on the service, every single day, right? And I think the great responsibility of continuing that legacy lies upon us, right? I think each one of us. So I think that's the key takeaway for today as we celebrate his 95th birthday. Okay, thank you, Sairam all. So let's get started with our class today. All right, so I'm going to share my screen. Okay, so we were actually looking at load balancing on last Friday, right? So I'm not sure if how many of you got a chance to get your hands dirty with load balancers. Can you please raise your hands, those who were able to do a lab exercise on Friday with load balancers? Oh, okay, quite a many. Okay. Excellent. Okay. All right. And okay, so what we'll do today is, I mean, this is our curriculum. I'm just opening our plan. So we are in the week of November 23rd. So we are slightly ahead, right? So we completed our load balancers and health checks, right? And in fact, this week, we were supposed to actually do a lot of hands-on exercises with load balancing, right? With auto scaling, highly available architecture, and so on and so forth. So I think we will continue with that. I mean, we'll continue with the rest of the sessions on the scheduled dates. But today, what I'm going to do is I'm just going to do a recap of the load balancers and health checks. And I'm also going to talk a little more about the different types of load balancers like ALB and NLB, right? I mean, these are the two load balancers that you should understand, right? Let's do that. And also I'll talk about web application firewall today, because that goes hand in hand with a lot of other services, especially at a layer 7 where you have your application layer and you want to have a security at your web application layer, right? So how do you achieve that, and what is the service that brings these capabilities out of the box is something that you're going to see now, see today. And these are the 2-3 topics that we will continue today, and then from tomorrow onwards we can actually start with the EC2 AutoScaling, because AutoScaling is a very, very important topic. AutoScaling is the one which helps you use the power of cloud. I'm sorry, just give me a second. I'm having some issues with internet. Let me I'm back. Is my voice audible?
Yes, it is.
Okay, all right. So I'm just going to share my screen again. Okay. So yeah, so EC2 autoscaling is a very, very important topic. That's the service that makes you use the power of cloud. And that's the service that makes you build fault tolerant, resilient, highly available applications, right? So that's a very important topic for you going forward. I mean, for interviews or even when you have to uh, build some assignments for your interviews and things like that. So it's going to be very, very important, right? So that's something that we're going to see for the next 4 days, from tomorrow to Friday. It's going to be a lot of hands-on, right? So I'm going to request all of you to come ready with your lab credentials and do these exercises. So for the next 4 days, it's going to be quite important. After that, the next week, we're going to focus more on serverless architecture, right? So that's the cloud native architecture. I'm going to explain about that later. What is serverless and how do you make use of serverless? In fact, serverless architecture is the way forward, and a lot of organizations are, a lot of application developer, a lot of products are adopting serverless architecture because they don't want to manage the infrastructure anymore. They've just left it to the cloud service providers like AWS, right? So where the heavy weightlifting, the undifferentiated heavy weightlifting is given to providers like AWS, whereas they only focus on writing their source code, right? So that's where serverless architecture plays a major role, and it's a very, very important topic. So next week we're going to actually see that, and we are actually going to do a hands-on lab in building a complete serverless web application using Lambda functions, API gateway, DynamoDB, and things like that. So that's something that we're going to do next week. So these 2 weeks are going to be quite important because we are going to do projects. We're going to do 2 important major projects over these 2 weeks. So I would request all of you to pay good attention and derive the most out of it. Okay. All right. So load balancing. Let's come to the load balancing. So what is a load balancer? A load balancer is a service that can distribute the load across multiple different targets. Right. And load balancing is a common technique that is used to scale your application, and that is used to ensure that you protect your application from underlying failures. So that way, even when one node goes down, there is another node available, and load balancer can send that traffic to the other node. So this is like a redundancy built at scale, right? And there are different types of load balancers. I mean, load balancing is not a new topic. Load balancing has been there in the IT industry for a very long time, right? So in fact, earlier days, there used to be hardware load balancers, right? So where you had a hardware device, right? And that hardware device would load balance the backend targets. Okay. And then came the virtual appliances. So now then came software load balancers, right? Then like Apache is there. Apache is also can also be used as load balancer. Okay, where you can write proxy pass rules, and then you can just use a Apache as a load balancer to load balance your backend services such as your application servers, web servers, and whatnot, right? But in the world of cloud, load balancers are a very, very important service, which comes out of the box default, and configuration of load balancers in the cloud becomes very, very simple, and it's not something which will take a lot of time, right? I mean, you can just with few clicks of a button, you'll be able to provision a load balancer, right? So that's the advantage of load balancing. So what are the different types of load balancers, right? We spoke about application load balancer and network load balancer, right? So application load balancer is best suited for load balancing of HTTP and HTTPS traffic, right? It can only do HTTP and HTTPS. It can't do anything else, right? And when you have applications that are running on HTTP and HTTPS, it can be a web application, it can be APIs, it can be REST APIs, right? It can be anything. It can be a static web page, right? HTTP, HTTPS web page, anything, right? It can like what we saw the other day. We did an example of we did a small lab of how you load balance a simple hello RPL champs web page, right? So where it was coming from being served from web server 1 or being served from web server 2, correct? So that way, again, microservices. These days, microservices are quite getting popular, right? And applications are using microservices architecture more frequently, right? And legacy applications are being re-architected to use modernized microservices or container-based architecture, right? So now application load balancer is specifically targeted for layer 7 traffic for those modernized applications where you need a layer 7 load balancing capability with a lot more features, such as you can use the path based routing where you say that /blog it has to go to one server, /sales it has to go to another server, right? /help it has to go to another server. So that kind of path based routing is possible in application load balancer, right? And you can also do a query string based routing. You can do um, uh, a host header based routing, right? So you can use one load balancer and you can load balance multiple applications within that one single load balancer, right? Within one single application load balancer. So that way you can add as many rules as you want within an application load balancer. And certain quick info about application load balancer with respect to how many requests that it can support and things like that. I'll just show you. So in fact, it's a scalable thing, right? Where you don't have to worry about the capacity of the underlying load balancer, right? Where it automatically scales in and scales out transparently. You don't need to worry about scaling the load balancer by yourself, right? And you can just do it. You can just focus only on your application. The rest of it is taken care by the load balancer in terms of scalability, and it also provides you the ability to uh, offload a certificate, an SSL certificate. Like you browse any web page which is secure, which has HTTPS in it. Next to that, you see a small lock symbol that shows the security, that shows the secure certificate, SSL certificate of that website. So in this case, the website is aws.amazon.com. Amazon has a trust authority. It has got a certificate authority. Amazon themselves have issued the certificate. And yeah, if you see here, it captures, as part of the Ssl handshake, right? It captures, all the details about the user. I mean, details in the sense about the client, right? And then it basically uses this to encrypt, right? If you see here, it also tells you how many times I have visited this website prior to today. 12,680 times I have visited this website. Okay, and if you see here, it tells you a lot of other information. So anyways, I mean, so SSL certificates are also very important. In fact, I have been emphasizing on the need for all of you to understand the SSL handshake process, right? How SSL handshake happens, like similar to how TCP handshake happens. You also need to understand how SSL handshake happens, so because it's very, very important for you to understand. That's a important interview question. I can point you some resources for SSL handshake. Yeah, so you can just read through this. Okay, so SSL handshake, how it happens. I mean, how the initial exchange of keys happen, right, between the client and the server. It's a very interesting process, right? You can just read through this, right? Or you can just search for it. I mean, you will find a lot of nice articles about SSL handshake. Yeah, Medium is also good. Mediums is also good. Okay. Yeah. So this is basically a TLS handshake. Okay. So where the client first sends a SYN packet to the server, the TCP packet, a server responds it with SYN ACK, then client sends a ACK packet, and then client sends a client hello to the server, right? And then what the server does is it basically sends a server hello done packet back to the client, right? And then this is where the TLS handshake happens primarily for the first time, right? So then what happens is the server sends its public key to the client, right? So then the client takes the public key, stores the public key in itself, and whatever data that is being sent from the client to server is encrypted using that public key. So that way, over the wire, when it goes, it does not get decrypted. I mean, nobody will be able to decrypt it. So once it reaches the server uses its private key to decrypt that and use that data. Okay, so that's basically where it. Yeah. So, anyways, I mean, it's quite interesting. You know, there are so many YouTube videos also available. Let me just show you, point you to a few YouTube videos. Ssl Handshake. Yeah, you can view one of these videos. They're really good, right? So how the Ssl Handshake works. Okay, it gives you a complete understanding of it. So, so let me get back to the point. So the thing is, you can upload a certificate in the load balancer instead of putting it on the server. So that way, it's called SSL offloading, right? So where the offloading of the SSL happens at the server, happens at the load balancer instead of happening at the server, right? And any traffic between the load balancer and server is anyways within the private network. It goes as plain unencrypted traffic, which is fine. But anything that comes over the boundaries or which crosses over the boundaries, I think that is what needs to be encrypted. And that's where you need to terminate the SSL certificate either at load balancer or either at the server level. Okay. Yeah, you can also deploy it in both the places. You can deploy it in both the server and also the load balancer. So that way, the end-to-end traffic will be encrypted. From the client to load balancer will be HTTPS. From the load balancer to the server will also be HTTPS. Okay. So where the application load balancer, it recreates the request as it comes to it, and then it adds a few headers, few additional headers to identify. And that's where it basically does the apply those rules such as path-based rules and host-based rules and all of that. Okay, that's basically the application load balancer. Then comes the network load balancer. So network load balancer is at a slightly lower level or a much lower level at a layer 4, right? Layer 4 is transport layer, correct? So a layer 7 is application layer. So now, since it is at the layer 4, it is much faster than the application load balancer, because application load balancer has got the slight overhead of taking the request and then looking at the request, looking at the HTTP request, decrypting that request, and adding additional headers, and also apply the rules on top of it to send it to the respective targets, correct? So that way, there is a slight additional overhead involved with this process. Whereas in network load balancer, it doesn't work that way. Simply network load balancer passes through the TCP traffic. It does not inspect the traffic. It does not apply any rules, right? It does not encrypt or decrypt the data, right? So that way, network load balancer is quite fast. And whenever you need extreme performance, right? So where you want you can't add this additional little bit of overhead to your application requests, then go with network load balancer. And network load balancer does not work at HTTPS. It works at layer 4, which is TCP, UDP, or TLS. Okay, TLS is transport layer security, where if you want to use a certificate, right, you can go with the TLS, where you select the TLS and select the certificate, and then it will basically take this through. It'll be right? Your endpoint will be a TLS HTTPS endpoint, which is like a TLS endpoint. Okay, if speed is required, then you have to go with network load balancer. And network load balancer routes traffic to targets within VPC and is capable of handling millions of requests per second while maintaining ultra low latencies. Right, ultra low latency is very, very important. Okay, so that's basically, and forget about classic load balancer. Gateway load balancer probably it's a service which was just launched recently, couple of weeks back. Gateway load balancer is again, for running third-party virtual network appliances, right? So it's usually for a partner ecosystem, so you don't have to really worry about it. Application load balancer and network load balancer are the two things that you definitely have to get an understanding of. Okay, so I'll just play this video, short video.
Elastic load balancing improves an application's availability by distributing incoming traffic between two or more Amazon Elastic Compute Cloud or Amazon EC2 instances. Elastic load balancing routinely checks the health of each load-balanced Amazon EC2 instance. If Elastic load balancing finds an unhealthy instance, it stops sending traffic to the instance and reroutes traffic to healthy instances. To get the most out of this video, you should already have an account with Amazon Web Services, have signed up for Amazon EC2, and have created at least 2 Amazon EC2 instances with active HTTP servers. Important: the load balancer you're about to launch will be live and not running in a sandbox. This means that you will incur the standard Elastic load balancing usage fees for the load balancer until you terminate it. The total charges will be minimal, typically less than $1 if you complete the exercise described here in one sitting and delete your load balancer when you're finished. For more information about Elastic load balancing usage rates, go to the Elastic load balancing product page. Defining a load balancer. To define a load balancer in the AWS Management Console, navigate to the Load Balancers in the navigation pane. The console displays the Load Balancers pane. Click Create Load Balancers. The Define Load Balancer page of the Create a New Load Balancer wizard.
Interface has changed completely. So let me just pull up the, the concepts are same, but the UI look and feel would be quite different. I'm just going to pull up my account for a minute. So let me stop it. Yeah, I'm back. I'm just gonna share my screen again. Yeah, so here we have, right? So you go to EC2, correct, and go to load balancers, and yeah, click on create a load balancer, right? And you get options like application load balancer, network load balancer, and classic load balancer. As I said, classic node load balancer will get deprecated in some time, so it's not required that you completely learn. You can still learn it. Okay, because that's like a previous generation, so it's gone. Okay, so now here you clearly see that application load balancer support HTTP, HTTPS. Network load balancer supports TCP, TLS, UDP. And when you select application load balancer, you get an option to select an internet facing or internal, and then you can provide the protocol. It's listening. What is it listening on? Right? Is it listening on HTTP or HTTPS? You can add multiple listeners. You can add a HTTPS listener on different port, and you can add multiple listeners. I want it to be listening on 8080 also. You can say that. So that way, when requests come on either of these ports, load balancer is going to process those rules. Okay, and then once you create the load balancer, then you will be able to create the rules, and you can create host based rules, or you can create path based rules, right? Host based rules is, what is a host header? Host header is, this is the host header. In any website, the one that you see after HTTP or HTTPS till .com or .io or .org .edu, or correct. So that's called the host header. Okay, this is the host header. Okay, any website, if you see, this is the host header, right? I mean, if you have www.example.com, www.example.com is the host header. Okay, and so that's how the DNS resolution happens. So the DNS resolution actually happens from here. It starts with the top level domain .com, and then it looks at the domain name, right? And then it looks at the CNAME. It looks at the CNAME of the domain. So the first one is always the CNAME. If you don't have a CNAME, it's just a naked domain name. Like, for example, if you have google.com, okay, if you see, if you remove the www, this is a CNAME. It's called a CNAME. So if you just remove it, you'll still be able to access google.com. So that google.com is the naked domain name, right? So that's called a host header. So you can create an application load balancer and load balance multiple applications using that, right? It could be www.example.com, example1.com, example2.com, right? So that way, you can host multiple websites, and you can load balance multiple websites using one single application load balancer. So we saw this example the other day. Okay, so let's come back and let's look at network load balancer. I'm going to create a network load balancer today. So when you say create a network load balancer, again, it gives you a similar set of settings. What is the name? Let's give my network load balancer. That's the name that I'm giving. Is it internet facing or internal facing? I'll just make it internet facing. And what is the protocol that I wanted to listen on? Is it TCP? TCP is like normal. You can give any port here. TCP port 8080, port 80, or anything, any port, all right, any TCP port primarily. Or it can be a TLS. TLS is again 443, correct? So if you take HTTPS, right? HTTPS is a application level protocol, right? Application layer protocol, layer 7 protocol. But the underlying TCP protocol for that TCP protocol would be secure TCP, right? Which is TLS. It's called TLS. The TLS, the corresponding port number is 443. Any website that you see with a lock symbol like this and which has HTTPS is actually running on port 443. That's the standard port, right? So now you can just select TLS and add the listener, or it can also be UDP. Okay, UDP is used for multiple things. Like, for example, when you do ping, right? So ping is basically goes over UDP. Right, uses UDP as the protocol for completing the ping, because like TCP is quite robust and quite reliable protocol, because in TCP has got retries. If a packet gets dropped, TCP can retry for that packet and get that packet once again from the source. But UDP is not like that, and TCP has got an acknowledgement mechanism. For every packet that you send, you receive an acknowledgement from the client that the client has received the packet or the server has received the packet. So whereas in UDP, it's not like that. In UDP, it's a one-way communication, right? You just fire and forget. There's no acknowledgement that comes, and there's nothing of that sort that comes in. So UDP is completely one way, and you request for some data, server will just throw that data to you. It will not wait for any confirmation, right? And there is no way to retry. If there was a network glitch in the middle and packets are lost, okay. UDP is good for certain scenarios like DNS resolution, DNS query, right? If you want to do your DNS queries, all those DNS queries happen over UDP protocol. Okay, and if you want to ping goes over UDP protocol. And there are some applications also which uses UDP to avoid latency and to avoid slowness. Okay. Okay. So these are the things. So now what I'm going to do is I'm just going to add TCP port 80 as the listener. Okay, at a lower level. Okay, and then I'm going to use my VPC. I'll put it again in both the subnets, subnet 1 and subnet 2, right? And okay, space. Yeah, just next configure the security groups. Okay, so now if you remember, if you go back to Friday's session, we configured a security group for our application load balancer and attached that security group to the application load balancer, like how we used to do it for EC2 instances. Whereas in network load balancer, you cannot associate a security group to the network load balancer because network load balancer is just a pass through, right? It does not do anything. So it does not have a security group of its own, right? So now if you want to create a security group for your network load balancer, the underlying target security group applies to the load balancer also. So that way, load balancer simply takes the traffic and it passes through. It does not do anything. It does not inspect the traffic. It does not do anything. Okay, so now routing is where you have to again create a target group. Let me just create a target group. My NLB target group, and then TCP port 80, protocol is port 80. Again, the same set of health check, 30 seconds. I'll just go register targets. I don't have any targets right now. So I'll just simply, I can register it later. So I'll just go ahead and create this first. Yeah, okay, I've just created this. Okay, it's provisioning currently. So let it provision. So if you see here, unlike ALB, you will have this rules here, right? You will see a similar interface even for ALB, but in ALB you will have rules forward to target group, and then you will also have rules here, and this will be HTTP. It won't be TCP in the case of ALB. Whereas in the case of NLB, it is like you have a TCP and you don't see any rules because it's simply a pass through, correct? Okay, so what I'm going to do is let me just go back and create a new EC2 instance. Let me launch an EC2 instance. Okay, let me see if I have the AMI. Is the AMI available, which I created last time? Yeah, I have it. So let me just use this AMI to launch an EC2 instance. Okay, I'm going to use this AMI. Next. Yeah, so I'll just provision it in the private subnet. I don't want it to be in the public subnet. I'll just provision it in the private subnet. And then next, just add tags, name, web server 1. Next, okay, configure security group. Okay, this is where the security group for EC2 instance will act as the security group for load balancer also. Okay, I mean, not in a direct way, but yeah, it just simply does a pass through, correct? Okay. Okay, here I have to change the source to allow the load balancer. I can do that. Come back and do that. Next, and launch. Okay, then launch instances, select G2.micro, launch one more EC2 instance and same subnet 1B. Click next, add storage, add tags, add a tag, name, web server 2. Use the same security group, review, launch, RPL mobile app, acknowledge, launch. Okay, so yeah, so it's coming up. So let it come up. In the meantime, what I'm going to do is I'm going to slightly modify the security group to allow the traffic. Let me go to the security group. In the meantime, let me check if the load balancer is provisioned. Yeah, load balancer is provisioned. What I'm going to do is I'm going to grab the IP address of the load balancer. Okay, so if I have to get the private IP address, let me just do an NS lookup so that I can only whitelist. Okay, so that's the public. Okay, so what I'm going to do is I'm just going to go and change the web server security group to, let me change the inbound rules to, this won't work any longer. So I'm just going to remove this. I'm just going to whitelist my range of private IP address range, which is 10.0.0.16 VPC's range, so that I allow the load balancer, because load balancer is also sitting in the VPC, right? So load balancer will have one of the IPs that is present within this range, correct? So it's just going to allow that. So let me just save. Yeah, so that's done. So let me just go back to EC2 instances. Okay, see if the EC2 instances come up or not. Yeah, it's coming up. So I'm just going to fire my public EC2 instance. So that I can log into that and I can check what is the, I can go ahead and modify the HTML page to say that this is being served from web server 1 or web server 2. Okay, 372.38.6. Okay, I'm just going to go and bring up my Windows instance, put it into that. Okay. Okay, SSH -I RPL mobile app. I'll just grab the IP address of my web server 2, because web server 1 has already got the text as web server 1, so that's okay. Just going to connect to that. Okay, sudo su cd/var www.html. Okay. Oh, okay. Sorry, I didn't select the. What was the AMI that I selected? I think I made a mistake there. Did I select the right AMI? ES70, correct? Okay, let me just go back to the AMIs. Oh, okay, I didn't select this AMI. That's a problem. That's the mistake that I did for the second web server. For the first web server, I think I selected the right one, but for this, I did make a mistake. First web server, it is the AMI, yeah, web server golden image, right? Okay. Okay, I have to unfortunately destroy this and recreate it. Let me recreate this. Terminate instance, terminate. Let me just go to the AMI and again launch it from here. T2.micro, subnet 2, next add storage, add tags, name, web server 2, configure security group, choose an existing security group of web server SG, next review launch, launch, okay, it's still loading. Yeah, okay, mobile lab, just select this, launch the instance, view instances. Okay, so let this web server 2 come up, just give it a few seconds, 15-20 seconds for it to come up. Okay, 10.02.36. Yeah, it's running. So let me just go here. Okay, I'll just say sudo su cd/var www html. Okay, index.html, vi index.html. Okay, I'm just going to make this as to served from web server 2. Save it. Restart my HTTP service. Okay, it's restarted. Okay, so now I'm not going to even log into my web server one because I know for sure that it's running and I don't need to change anything there. So what I'm going to do is I'm just going to go back to my load balancer and I go to the target groups. So it uses this target group, my NLB target group. So I'm just going to the target group. Let me open the target group and I have all of these settings. Okay, it's running on port protocol TCP. Traffic port is being used. It's just a pass through, just port 80. So let me just go here, targets. I'll just say register targets. I'll register web server 1, web server 2. Just going to register. Yeah, so it's being registered. So let's just wait for a 15-20 seconds for this to turn healthy. So let's see what happens. Let's just give it a minute for the targets to get registered. Okay, let's just give it a few more seconds. I think it should come back. It should turn healthy shortly. Okay, because you can access this. In fact, we can just do a curl. I'll just grab the IP address of, say, web server 2, 10.02.36, correct? And just do a curl. Yeah, see, it's responding. So similarly, curl 10.02.97, correct? Yeah, it's coming from web server 1. Okay, so let's just wait. It should turn healthy anytime, right? So once it turns healthy, right, so what will happen is we'll have our load balancer, which is anyways active and running. So we can just use our DNS name of our load balancer to point to our application, to browse our application. It shouldn't take too long. I don't know why it's taking too long. Ideally, it should just come back quickly. Let me just review all the settings once again. Health check settings are on TCP, traffic port, healthy threshold is 3. Yeah, obviously it won't browse because the target groups are still not healthy. Yeah, it turned healthy now. Yeah, it took a while. Yeah, but it turned healthy. Okay, so now let me just stop this and refresh this. Okay, there's one more problem here, right? I mean, it won't browse. You'll get a timeout. Can somebody guess why? I have my load balancer. My network load balancer is there. It's just forwarding the traffic to this target group. This target group has got 2 targets associated with it. Okay. So now it's still not accepting traffic on port 80. Okay. The reason being your EC2 instance has got a security group associated with it, correct? So now in the case of application load balancer, you had a security group attached to the application load balancer directly, whereas in the case of network load balancer, you can't attach a security group directly to the network load balancer. Whatever security group that belongs to the underlying EC2 instance, that applies to the network load balancer. In this case, the underlying EC2's security group is basically saying that you will only allow traffic from 10.0.0/16, but you're not allowing it from the world. Okay, so that's probably why you're not able to access the traffic coming from the world. Now I'm trying to access it from 0.0.0.0, correct? Because 0.0.0.0 means any traffic. Okay, whereas if it comes from, whereas I'm only allowing the traffic to come from 10.0.0.0/16, right? And and that's the reason, earlier I said that you can put a 10.0.0.16 and then it will try to allow the traffic only from network load balancer, but that is not the case, right? It won't be able to allow because your network load balancer doesn't have a security group of its own. It uses the underlying targets security groups. Okay, I'm just going to go modify that security group to edit inbound rules, remove this and say 0.0.0.0 and save. So the moment I do this, and once I do a refresh, okay, there's one more thing, that there's a mistake here. It can't be HTTP, right? And I'm trying to hit it as HTTP, correct? HTTP:// and it's not working, right? So now the moment I change it to TCP port 80 and say okay, this. At the end of the day, it's all HTTP only. One sec, let me troubleshoot what is happening here. Let me go back to my target group. My target group has got a listening on TCP port 80, which is good. Let me go to the load balancer. Load balancer listening on. Let me edit this listener. It's on TCP port 80. Okay. Okay, requests are hitting the load balancer. In fact, if I see this requests are coming to the load balancer. And if you see, around 6 requests have come. I was trying to send it, but the load balancer is not able to pass it to the target. So let's troubleshoot that portion. Okay, their target, they're healthy. Okay, healthy hosts are good. Target, they're good. Okay, let me do one thing. I'm going to troubleshoot this and come back to you in tomorrow's session. as to why this is not working. I just need to figure out why this is not working. So let's do that. And so now let's slightly shift gears to WAF, Web Application Firewall. Okay. So what is a Web Application Firewall? AWS Web Application Firewall. Okay. So now, so when you host your web applications on AWS, right, or for that matter anywhere, right? I mean, you need to have a protection to the web applications, right? So how many of you know what is a DDoS attack? DDoS. Can somebody unmute and explain? Yeah, Z003, Z005. Yeah. Can you unmute and explain what is DDoS attack is? Yeah, please unmute yourself. Yeah, I think somebody raised your hands. Z003. Okay. Anyone else would like to give it a shot? What is the DDoS attack? Distributor denial of service. Okay. So basically, it's a kind of an attack, where a web server or a service or a server is continuously being bombarded with requests. Okay, and when such requests are being sent in a very, very coordinated fashion continuously, it does not allow the server to cool off, right? You're continuously putting the server, stressing the server, and it goes to 99%, 100% CPU utilization and 100% memory utilization, and the server crashes. Okay, so that's called the distributed denial of service attacks. So now what happens is typically there's something called OWASP top 10, right? OWASP top 10 security risks are something that you all need to understand. Especially if any of you are interested in doing application development, it is very important you understand the OWASP top 10 security risks. So now what happens is usually when there are specific attack patterns that are coming on your websites or your web applications, right? Let me just go to OWASP top 10 and search for it. So there is a site called owasp.org. So these are the top 10 security risks. You can learn about it. Sql injection. How many of you know what a Sql injection is? What is a Sql injection? Sql injection, right? SQL injection is where if you're not so when you build your web applications, your data access layer will have its query to run on the backend database, correct? So now that when you don't secure that, what can happen is potentially a hacker can come. A hacker can send a delete star from users table, right? And he can potentially run that query and delete all your user data. Okay, so that's called SQL injection, right? Similarly, there's something called broken authentication, sensitive data exposure, XML entities, broken access control, cross-site scripting, right? Cross-site scripting is where when there is a cross-site scripting flaw that is there in your application, you basically allow your untrusted data in a new web page without the proper method to validation or escaping your data, right? So that's where people browser applications that use HTML or JavaScript extensively are vulnerable to cross-site scripting. Okay, insufficient logging and monitoring, right? So anyway, so these are the 10 top web application security risks that would put your application at risk, that would put your website at risk. So now WAF is a service which sits above your application, web application, and which filters all your traffics and send it to the load balancer, or which can send it to your application. It is not a load balancer, but it's a firewall where it receives all the requests, HTTP requests. It inspects the HTTP request, and then it looks at if there are any of these top 10 vulnerabilities there in your web application web request. It filters all those requests and then it rejects it. I'll give you one example. In a WAF, what you can do is you can block requests coming from certain specific countries. Okay, if say there are certain specific countries that you think are going to impact your website, or traffic coming from those countries are going to impact your website, and there are hackers funded by, say, terrorist organizations who are defacing your websites continuously. Correct. Recently, there were some attacks on Indian government's web pages. Correct, or some state government's web pages, government websites. Right. So they are continuously trying to deface your website, and then they're trying to basically attack your website continuously. Right. But you want to anyways fix all those vulnerabilities so that your website becomes a lot more secure. But that's a time consuming process. You need some time to identify the root cause, fix the code, redeploy the code. Correct. But you won't immediately block it, right? You're seeing that there is a set of IP addresses that are continuously trying to hit your website, right? I mean, if say there is a user pattern, let's say I'm accessing, like, say, google.com, I would just say go to google.com. So the request will originate from my IP address, and it will go probably once in 10 minutes or once in 20 minutes, right? I mean, probably I did it about once in 5 minutes, right? I went to google.com. But imagine I'm running a program that is continuously hitting google.com. Okay, it's continuously hitting google.com, right? Every minute it's sending like about 1,000 requests. So in such cases, it is not used by a human, right? It is actually used by a bot, or it is used by a malware, which is actually trying to hit the google.com website continuously with a malintent of bringing down the website, right? In such cases, what WAF does is WAF looks at the pattern of requests that are coming, right? And the moment it sees that it falls within those one of those vulnerable patterns, it immediately blocks it. It will not allow the request to go to the web server. The WAF service itself will block it. It will put a rule in it saying that block this so-and-so IP address, block this source IP address, and then that source IP address will be completely blocked. It will never pass through internally. Okay, so that's where, if you see, WAF is a service which basically you can put it in your perimeter. You can put it for your CloudFront. All of you remember CloudFront, correct? We worked with CloudFront, and we built a S3 web application using CloudFront. And you can put it in front of load balancer, or you can put it in front of an API gateway, right? API gateway is something that we're going to see next week. But these are the three resources with which you can work. You can get your WAF. WAF is a layer 7 firewall. Unlike your layer 4 firewall, you have other firewall devices, correct, or appliances. Your WAF is layer 7 firewall, and it basically allows you to secure your web application against your top 10 web vulnerabilities. Okay, so I'm just going to see if there are videos around WAF. Okay, I don't have the I don't have the thing that says that short video, the product video. That would have been ideal to watch, but that's okay. You can watch other videos about WAF, but just remember that WAF is a service which will allow you to protect your web application, and it will basically disallow any vulnerable patterns that are coming to your web application. Okay, and you can use it in front of load balancer. You can use it in front of CloudFront and things like that. Okay, so let's do one thing. Let's take a pause here, right? And we are going to start tomorrow at 9 o'clock with auto-scaling and high availability architecture. Auto-scaling is going to be a very important topic. In auto-scaling, we will use ELB and we will use health checks, and we will automatically scale the number of EC2 instances that are running, right? So that you're able to dynamically respond back to the business, right? It's basically at a business scale, right? You're making your infrastructure respond to your business growth automatically, right? So that's what we're going to look at tomorrow, and it's going to be important. You complete your load balancer exercises. If any of you who did not get an opportunity to complete your load balancer exercise, please do complete. And if any of you have any doubts or clarifications on load balancers, you can just watch Friday's video, right? And follow the Friday's video and access the load balancer from Friday's create the load balancers and create the set of steps that I've given on Friday to complete those exercises, because it's going to be really important for us to complete our lab exercises for the rest of the week, because the next 4 days are going to be around building resilient, fault-tolerant web applications. We're going to build a WordPress website, right? The same WordPress example that we took. We're going to build it and we're going to make it fault-tolerant. We're going to use auto-scaling. Auto-scaling has got so many settings in it, right? So you need to understand all of those settings. In fact, I'll just go there. If you see, launch configurations, auto-scaling launch configurations are there, right? And you've got auto-scaling groups. Okay, so we're going to see this tomorrow, right? Auto-scaling is a very important topic. So the next couple of days, we are going to do lab exercises around auto-scaling. I'm going to give you some scripts. I'm going to give you some lab material for you to complete the auto-scaling exercise. Next couple of days, we're going to have classroom sessions. But Thursday and Friday, you're going to do a project of your own, right? I'm going to give you a topic for that project, and all of you are going to do that project of your own on Thursday and Friday. Okay, so let's just take a pause here, and let's again meet tomorrow morning with auto-scaling groups. We can start with that, and I'm also going to come back to you on why this is not working. Let me do some troubleshooting and come back. And we're going to do it tomorrow. And WAF, you can just go through the web application firewall, the documentation. I mean, you don't have to do a hands-on, because WAF is not a free service. So you don't have to do a hands-on. So just do read this and do watch any videos that are available. Most better thing is to just go to resources and go to the product documentation, developer guide, and open the developer guide and go through the developer guide. That's going to give you good insights. And also towards the end of this course, I'm going to hand over a bunch of documentation. I'm right now collating all of that. Give me some time. By the end of this course, I'm going to give you a booklet which will have all these links that we have seen over the last 2 months, all the resources plus any other additional resources that I feel are important for you, right? And I'm also going to give you some small snippets of tips, right? For each of the topic that we have covered, I'm going to give you some tips so that when you're going to attend interviews, you can read through those tips. It's like a cheat sheet, right? You can use that cheat sheet. Of course, don't use it in front of your interviewer. Okay, he's not going to, nobody's going to tolerate that. But yeah, it will be a good cheat sheet for you to sit, relax, and go through that before the interview. Usually there is a 11th hour study, right? So you can go through that cheat sheet and go through service by service. What are the key things, right, for you to remember, right? So the moment the interviewer asks you that, you can immediately visualize that cheat sheet and answer it from that. Okay, I'm right now putting together all of that material together so that by the end of this course, I'm going to hand over all of that to you as a single booklet, right? And you can refer to that anytime, right? And you can use it, pass it on to your friends, and you can use it for your further studies, and you can use it for further references, and that will have GitHub links, and that will have so many other links. Like there's something called architecture blogs. I'm going to give you those architecture blogs. It will have standard patterns, and you can use those patterns to build applications. Okay. Okay. All right. So then let's kind of take a pause here, and well, I'll see you all tomorrow. So you can go to your breakout rooms and start practicing. I mean, if you've already practiced the Fridays, I see that about half of the class raised your hands. If you've already practiced it, do it once again and read the WAF material from today. And if you have not done that, if you have not practiced it, just take this opportunity to practice the load balancer. I mean, those who have already practiced, that's okay. It doesn't hurt to again practice it, because you'll have to practice it several times, right? So just practice it and then destroy the environment. And I'll see you all tomorrow.
Sure.
Okay. All right. Sure. Thank you. Thanks all. Thanks, Sai Krishna. Maybe students can go into their breakout rooms.
Saira, like one of the student has doubt. Like yesterday, you told you'll be joining the breakout room.
Okay, sure. I will join the breakout room.
Yeah.
Sure, I'll do that.
May I know the student number? So
A16.
Okay. And A60, do you have any question?
Yes, sir.
What is that in regards to?
Sir, regarding to my building, account building.
A16, Prasanna sir is going to join your breakout room. He will help you there. I'm talking to A60, A60.
Okay, sir.
Yeah, I'm going to join the breakout room.
Okay,
A60
sure.
and A16, right? Both.
Anna, I'll talk to A60. I don't know what her issue is. I'll text you, Anna, so that you can join their breakout room as well.
Sure.
All right. Guys, please do accept the invitation for your breakout rooms.